guys, I'm Brent.
I'm Mike.
And we did a light cube, and we're using Tricolor LEDs for the lights, so we can flash any number of colors. Wow, that's bright.
Right. So the requirements is it's a 4x4x4 Tricolor LED cube. It must display patterns or random sequences that the user can kind of choose from, but there's no user input. It just runs through these sequences once it's powered.
And we kind of did that. We just wanted to keep it simple, just something you can flip a switch, don't have to know anything about, programming or using it, just turn it on and it'll go and look pretty. And I think that's kind of what we accomplished. So for the hardware, basically it's actually pretty simple for as hard as it looks. The main thing is just with the Tricolor LEDs, there's 3 cathodes for every LED, so it added a lot of wires. But basically all we have is a PIC microcontroller, which actually does all of the controlling circuits. It'll calculate the patterns, it'll keep track of the display. And what that does is that feeds our power control section, which is basically just 4 high current transistors. We have 1 line for each layer, and the matrix is multiplexed per layer. So basically we'll just turn 1 layer on at a time and then set the cathodes for whichever pattern we want using LED drivers. And the LED drivers are constant current, and they have 16 channels each. So we can basically say turn on channels 1, 3, and 5 to 20 milliamps or however much you want to set it, and then that'll turn those on. It's basically all we do is we just go through. And like I said, it's multiplexed by layer. Same thing if you guys remember 129 and 229 with the onboard 7-segment displays. It's the same concept.
As far as the software, going back to this portion, what we did was we had a main loop. It initialized everything that we needed to do, and then it just loops through these patterns, so it goes like one pattern to the next. And then we used the interrupt routine to actually do the displaying of the LEDs. The interrupt routine goes by through each layer, because we can only display 1 layer at once. It turns 1 layer on in the correct pattern, then it goes to the next layer, turns that layer on, and displays it like that. So it just does 1 layer at a time. The interrupt routine only handles displaying 1 layer, and then goes to the next, and once it's gone through all the layers, then it sets the next frame. And then for the patterns, it's pretty much, we have an array of bytes that just stores every single pixel of every color, pretty much. And then you just turn on the right LEDs and get the pattern that you want.
Yeah, so this is just a basic sample. It's going to turn one on, wait, turn one off, and then just keep going. But you can get as complex as you want with the patterns. It pretty much, whatever you can design is what you can make. And so part of the software, we wanted to keep all of the display handled entirely by the interrupt. And the reason for that is it allowed us just to keep everything separate. Since the entire display is being handled by the interrupt routine, the main focus is on just pattern generation. And so going back to the hardware, it was actually designed in my 458 class. And I'm going to do a shameless plug for that class real quick, because it's a lot of fun. You get to pick your own schematic, and you basically put the schematic in, design the board layout, they ship out the board to a company, and you actually get your specific board back. Put all the components together. It's a lot of fun. You don't have to do anything with a microcontroller. I just happened to do it, and it worked out well to combine the classes. But if you guys need tech electives, I would definitely recommend it.
Back with the software real quick. Also, with the software, the reason we use interrupt routine as well is because we need a fast enough refresh rate. So we put that on the clock. Otherwise, if it's going too slow, you'll see it flicker, and that's no good.
All right. So for integration, the main thing here was building the hardware. Like I said, a lot of that was actually done for the 458 class, but having that many LEDs and wires right next to each other, shorts was a big issue trying to build this. It's a little bit harder to see on here because of the colors, but this is a close-up of the LED, and you can see the just very, very close lines coming together. And then this was one of the LED drivers to solder it on. I don't know if you guys see, but this is a resistor here. just to give you guys a size comparison. And there's 24 pins total to solder, so I would recommend not using surface mount stuff if you ever have to build your own project.
Yeah, also testing is very important. We had one LED that turned green instead of blue, so we had to replace that as well.
Even after, yeah, we seriously, I went through, we tested every single cathode of every single LED before we mounted the board, and once we got it all together, we still had to go back and pull one out and do some doctoring just because I didn't even know what happened. It must have gotten tweaked or something. It was, like I said, once we replaced it, it worked fine, so it must have just been a bad LED.
Oh, and one last thing. With these guys, we actually had to use a serial protocol to write to it. So it uses one pin to light up 16 different LEDs, rather than putting like 16 pins to 60 different LEDs. So that was another part of the design.
Yeah, and then another issue we had with testing was trying to get a new environment set up, just because there was like configuration bits for, we had all of the ports set to output, but then 2 of them still weren't working because we didn't know to go back and actually set the clock settings to say that those were not clock inputs or outputs, that they were actually digital inputs and outputs. So it was really weird getting to know a new environment, and that took some time as well. So we have our demo for you. Like I said, it's pretty simple. All we got to do here is flip the switch, and everything lights up. And like I said, it's just gonna go through a bunch of different patterns. These are actually, we're using the same patterns over and over again. You'll see it'll go back through them, but we can set them with different colors or pretty much whatever we want to do. And yeah, so that's pretty much our project. Do you guys have any questions? Yeah.
How much was the whole thing?
The LEDs were pretty expensive. They're about $25 for a pack of 100, just because they are the Tricolor. And everything else was about $20 total. The teacher paid for the board, but to get it manufactured for one board is like $25. So it was lucky that he paid for that. So I ended up spending about $50 total myself.